So I'd like to invite our other panelists to come up and join us up front, and for all four of you to have a seat up here. Please line up. I encourage you to ask questions specifically of Paul about his remarks just now, as well as to all four of our panelists. Start over here with Mark.
Okay. Well, as I look at this slide and the box on the right, it's pretty clear that unless we price carbon, cheap and abundant fossil fuels, whether it's gas for electricity or oil for gasoline, will simply obliterate the alternatives, short of mandates to require a certain amount of carbon-free power. My question, though, prompted by the remark about the nuclear plants essentially having to pay a penalty, and the question of load shedding. In California, part of the idea is they'll make hydrogen on sunny days, and that will power a transportation fleet of hydrogen cars, which I'm not sure I buy. But it would seem to increase the value or the economic viability of energy storage in one form or another, that rather than paying the penalty, if that could be invested in something that at least over time might have some payback. I realize there are existing technologies like Ludington, pumped hydro, there are emerging battery technologies. Do you see that as important to integrating nuclear into a more renewable future?
So actually, we are working on energy storage. The title of this was Game Changers. And there are two other game changers in the industry that I didn't even talk about. One of those is the ability to get viable storage, whether it's batteries or whether it's some other source of storage, is one, because that'll change. The ability to store energy from renewable sources clearly is a game changer. The other game changer is distributed generation, and having small local sources that can feed communities, cities, businesses, or even homes, neighborhoods, would certainly impact the need for baseload generation. So when you talk game changers, those I would say would change the economics for all baseload, not just nuclear. Of course, you wouldn't need those large baseload plants other than you still need to have a regulation on the system, and that's provided by those large baseload facilities. But those would be game changers. I think eventually both of those, I believe, are going to be viable in the future. That's something, there's a lot of research going on. We're testing storage out in the neighborhood using batteries, where we would store energy in a battery, and they lose power. The entire neighborhood would be fed off the stored energy in the batteries. We also have distributed generation. So I think that's going to change the future of the industry quite a bit.
I have an additional comment, and that's that some of the advanced reactor designs talk about delivering heat at higher temperatures, the right kind of heat. If you look at where carbon's coming from, it's just not production of electricity. In fact, making electrons is a pretty tough business. On the other hand, when you deliver the right type of heat, quality of heat at 500 to 700 degrees C or in that range, you begin to be able to make inroads into basic industry and the sort of products they make. And Southern Company and other places are looking at that rather intensely. And that would change things quite a bit as well.
One thing that we didn't talk about with Midland was that it was a co-generating plant that was supposed to have a third loop and provide steam. In general, these schemes, particularly those coming out of MIT, where's our MIT guys here? Okay? Charles Forsberg, for example, you don't talk about the cost of the other product. And a lot of times, the only way these things are going to work is if the other product is in a regulated market, and if electricity is a non-regulated market, you have to pay an enormous amount for the infrastructure. And these things, for example, if you're talking about doing oil sands in Canada, you've got a nuclear plant that is now, possibly going to run for 80 years, and you've got a mine that may be running for 20 years, and so then you have a stranded asset. So we can talk and talk and talk and talk and talk. If you want to talk to Charles, he'll talk your ear off. He can talk for 24 hours nonstop about hybrid systems. It's talk, okay? There's no economics. Nobody sits down and works out how much this is going to cost and who the contract is going to be with and how those capital costs are going to be recovered. Detroit Edison and Consumer Power aren't going to be putting in heat to homes, okay? This is what we have in Northern and Eastern Europe. We've got nuclear power plants providing heat to homes and businesses and so forth. Nobody would ever pay for that infrastructure anymore. And you've got to be realistic. Nobody sits down and costs these things out from the bottom up. I don't see this. And, I'm the chief economist, basically. And so if you're going to start talking about cogeneration and all the ways that we can use nuclear power, sit down and do the economics before you start talking about it. These people, my father's career was ruined at Midland. And one of the things was because they couldn't sell the steam. And so I'm very leery of talks about cogeneration, hydrogen. It's not that simple to, how do you price hydrogen? What is the price of hydrogen? Where's the hydrogen highway? Who's going to use this? Bus fleets, maybe, but it's not that simple. You've got to work on the accounting and the financing, the economics, before you start talking about cogeneration.
Fred.
Yeah, I'm neither an apologist nor a defender of Midland as a cogeneration facility, but I think it's important to remember that today we look at it with glasses that are very different from what we would have seen had we looked at it when it was originally conceived in the late 1960s. It was conceived at a time before there were energy markets, when all electricity production and delivery was regulated, and at a time when it was thought that the steam produced would be non-radioactive steam. One of the many blows to Midland was a decision in the mid-1970s there was no such thing as zero radioactivity in process steam coming from a nuclear plant, and that as a result there would be at least one intermediate loop required, which completely changed the design of the facility. Without arguing about whether or not that intermediate loop was a good thing or a bad thing, I think establishing the rules, both for the economics and for the content of the process steam or the process heat, before one starts down the road of construction becomes a very important thing to do. And I do think that Jeff is right in that before embarking on any kind of a process heat or a cogeneration facility, doing the math and doing it in the context of not only the way you see the world today, but the way you expect the world to be during the lifetime of that plant, becomes a really important thing to do.
We have a question asker waiting patiently over here.
Evan Kraus, Michigan Public Service Commission. My question is about markets and is tied to Fred's graph of capacity factors and overnight costs. That chart looked very reasonable to me from what I've seen. The question is, when we look at this as regulators, we often come in markets to one of two conclusions, is that we look at what we think these prices are going to be, and we either think there's going to be a dramatic spike in market prices due to the retirement of old coal and the addition of new resources to replace them, or we come to the conclusion that the markets are broken. And I'm curious if either one of those two things seems plausible, or if there's maybe another alternative option between it. Do we expect to see prices spike due to what's happening, or do we think that the markets are broken and actually not capturing all the value?
I'll take a shot at this. One of the things that seems to be evident to me over a lot of years in being in and around these markets is that spikes are hardly ever things that one can forecast in advance. That markets tend to be fairly smooth, and that there are disruptive forces, but they are unanticipated forces. If you have time to anticipate for shutdowns, retirements, new facilities, there tends to be smoothing mechanisms in place that ameliorate the effects of those changes. The changes that are dramatic in markets are changes where you wake up one morning and the world is different than it was the day before. So I don't anticipate spikes as the result of decisions to shut down or the decisions to build that are known well in advance. In terms of whether or not markets are broken, what I would say is I don't think so. But sometimes it's hard to tell whether or not a market is broken when you're in the middle of it. It's much easier to look back from 20 years from now and draw your conclusion then.
I'll tell you, it depends on your perspective and where you're at. Right, so this past summer in Michigan, I'll talk Michigan, in MISO, of course we're in MISO, so we had several times in the summer where we were reaching the limits of our reserve margin this summer. So we were down to 0.1% in terms of reserve margin, and we're beginning to notify our customers that we may interrupt you during. So we were at that, and prices were beginning to spike up, much less than in the past. 6-7 years ago, they would spike up to $4,000 or $5,000 a megawatt. The highest we saw in this past summer was about 150, I'll just say, somewhere in that ballpark. In those very hot days when we were, that close on the edge to the reserve margin. And so the real question becomes, as you continue retirements, MISO's really worried about maintaining reserve margins and who's building power plants and when are they going to come online. Because at some points we were dipping below the required margins. Out east in New York, they would tell you it's broken because they don't value their plants, right? And they have a market that we don't have, right? So plants provide megawatts, they provide regulation, stability on the grid, they provide ramping capability to allow fluctuations either for renewables up and down or loss of a large generating unit. Other units have to ramp up or down very quickly in order to account for that. And the markets don't pay for that in all cases. So I will tell you, it depends who you talk to. I think there's a lot of debate, especially in MISO, on are we going to have capacity markets? How much are we going to pay for them? And really show the true value of the generation. So it depends where you're coming from, I would guess, at this point.
Yeah, let me add that I think markets which pay for capacity and which pay for ancillary services are better markets than those that try and cover the waterfront by just paying for energy. But I think part of what markets are telling us is that it is better to pay several $100s per megawatt hour for a few hours a year than it is to pay an extra, over and above what we're now paying, an extra $10 or $15 a megawatt hour year-round 24/7. And so the markets are saying traditional reserve margins seem to be a little higher than what we're comfortable with from an economic perspective.
Jeff?
Okay, I'm going to warn you guys about economists. Okay, there is an ideology, pro-market ideology, that most economists advocate. Okay, don't believe it. The end goal is efficiency. That is what we're trying to achieve, and markets is a means, not an ends. And so I was standing there at Stanford at the board when the lights went out. The markets in California were busted by Enron, okay? And they can be busted by someone going in and manipulating the market. It's possible to manipulate markets. And so I would suggest that when you're talking for, the next one of these conferences, it's whether or not dealing with climate change and electricity markets are compatible. I don't believe they are. You have to end up with all these little, you've got to do all these little changes. So this is the question. Are markets compatible with reducing CO2? And I think they're oil and water. So that's what I would suggest that you do next time, is look at whether or not markets can address climate change.
I was going to ask you for a question very closely related to all of this, so I'm going to step in quickly before we take our next question. Something I spend a lot of time on with my students is, are high costs that you see reflective of resources going into production? And if so, there's no need for government to step in because those are society's resources. You don't want to build that thing that's really expensive because it takes a lot of society's resources to do it. Or is there some reason that the market is failing and that's why you're seeing high costs that aren't truly reflective of what society values? So we've mentioned CO2, we've mentioned capacity value, we've mentioned ancillary services. As you look across the scope of potential market failures, reasons for government to actively step in, what are they, and are they helping or hurting nuclear power at the moment?
Okay, the question is sustainability. Is this system of markets sustainable? Okay? When we use discount rates that, are what we call market discount rates, that means that we don't care about anybody that is being born today, okay? So one of the things regulators do is they look past the forecast horizon of the market, okay? Markets have a very myopic view of the world. So it comes down to, are we providing for our grandchildren? I've got a grandson now that I've been spending the last couple of days with, and I'll see tomorrow. He's 2 years old. That means he's going to be around for the whole century. What are we doing for the people that are being born today? And in the European Union, they're always talking about sustainability. They're always talking about the future generations. And, that means today's teenagers and 20-somethings, are they future generations or are they today's generations? Basically, the EC treats them as today's generations. They're not a part of the future. What are we doing about the future? Okay, and when we use cost of capital on the order of 7.8%, which are supposed to be comparative to, markets for electric utilities, capital markets, we're doing nothing for those people. We're telling them that your value, when brought back to today, is 0 or 0.15%. So somehow we have to figure out, if we're going to use markets, how we're going to be seeing the future.
This is a great observation, and it actually goes back to conversations that I had with staff at the Michigan Public Service Commission a long time ago, having to do with to what extent should new resources be paid for by existing customers, and to what extent should they be paid for by future customers. It gets into rates of depreciation, it gets into policies with regard to setting of rates and approving of new infrastructure, and a decision that was made in this state, and I think comparable decisions made in most states, is that in the tension between worrying about the customers of today and the customers of tomorrow, the customers of today vote, and the customers of tomorrow don't vote. And so we tend to be biased in that tension toward setting policy, building markets, establishing rules around trade, establishing rules around regulation that favor the people who are paying for energy today versus those that are going to pay for it tomorrow.
So we'll add one thing, right? In the markets I talked about in New York and Illinois, where the nuclear plants are under a lot of stress. I mentioned all the ones that were closing or potentially closing because the market did not value any existing zero-emission producers. So in a clean power plant, there's no credit for existing power plants. You only get credit if you build a new one. And so they could not compete with new gas generation. However, new gas generation is 60% of the emissions of a normal coal plant. And so you make a bad decision from an environmental standpoint. They force them to close down the nuclear plants unless they provide a subsidy and recognize the generation at zero emission, or you force them to close from an economic standpoint and replace it with something else. All that was market driven. That's why you have all those discussions in the New York legislation and the Illinois legislation that they're trying to drive through.
Great. I think we have time for 2 more questions, so we'll come over here and then Tom will have
That was
those.
a really great discussion you just had, and I thought a lot of it, it's a function of the discount rate and valuing what's important to future generations, which Sir Nicholas Stern has done a lot of work on that, as you know. This relates to my question. This is for Paul. It's regarding the Nexus pipeline that DTE is looking at investing $1 billion in. Their non-regulated subsidiary. And they're going to be, as I understand it, selling about 10% of the gas to the regulated company. And I was looking at some of the cash flow forecasts for it, and it shows that for the first 10 years, there are negative benefits of investing in this pipeline for years 1 through 10. And years 11 through 20, it shows a real nice increase in the value of the gas for this pipeline. Now this is gets back to the earlier discussion. This is a 60 to 80 year asset that we'll be living with for many, for our lifetimes. And I guess I'm just wondering, you made a really good point about the variability of natural gas prices, which we've seen for decades. It's very unpredictable. But yet, the forecast that was done by one of DTE's consultants shows this really nice forecast years 11 through 20, with this big return out there. And I'm just wondering how you square that with the volatility of gas forecasts and making that type of decision on a 60-year asset with no positive cash flow for the first 10 years.
Okay, so you're getting into an arena that I don't have a lot of information about, right? So on the gas side, I've been on the electric side of my career, so I don't know that I can answer your question very well. All I can tell you, I've looked at enough forecasts on gas prices, and there's 3 or 4 different companies that do this for a living. They all of them don't show the same volatility in the future that we saw in the past, and that's because of the nature of our ability, the reserves we have in this country, and we're not subject to the fluctuations when we were relying on foreign supply. So in terms of the economics, you've obviously looked at it. I haven't. I can't dispute anything you're saying, but the only thing I can tell you is it's a non-regulated business, and if they didn't think they'd make money on it, I don't think we'd invest in it. But I can't speak to the rest of it, to be honest.
But it does tie in with your regulated business.
No.
Because there's going to be about 10% of the gas purchased by the regulated business.
That's true, but that's all bid on, that's competitively bid. We are prohibited by regulation to cross over from a regulated to a non-regulated business unless it meets certain conditions.
Let's go to,
By the way, the question, while it was asked about a gas pipeline, is a question which is really the same question that one would ask about a new large Generation 4 nuclear plant. Investing a lot of money, no cash flow during the first 10 years, and then selling into a market which is very uncertain when looked at from today. And it is the kind of decision that utilities have traditionally made, and is one of the reasons that utilities have traditionally been regulated, to provide some protection against making decisions which are good decisions at the moment, but for which circumstances change by the time the asset goes into service. As we move from having a regulated environment to making the same kinds of decisions in a deregulated market, the risks become much larger because there is no floor of protection underneath.
I think that's a fabulous point. Brings us back to several things that you all spoke about in your discussion earlier. Let's give the final question to Tom Lang.
Gentlemen, thanks for a very insightful series of presentations. Fred Buckman made a compelling argument that construction delays are an important part of escalating construction costs. And I think the conventional wisdom is those are due to regulations and maybe public protests. But both Fred and John made the observation that one important thing to do is finish the engineering before you start the construction. And that's something that's actually within the control. That's a decision of the company making the plan. So I'm interested in how big a portion of the delays are due to that, and why do companies plunge forward with construction before they finish the engineering?
I'll start the conversation. I would say that virtually all of the construction delays are the result of things which are within the control of the plant designer and the plant constructor and the plant owner. I do not think that these are because of changes in regulation or because of public opposition or things of that nature. There was a time when I think those were important parts of it. But I think simply having the owner, the engineer and the constructor getting their arms around these big projects and running them efficiently is the real underlying problem today.
Yeah, I agree with that. Having spent a lot of time with people who are dealing with those problems today, the other part of it is if you're not building a lot of plants, you don't have the ready infrastructure of expertise and so forth. So it's harder to do. You can complete the design, but you turn around and you want to purchase certain components and other things. I haven't done it several times recently. It's a harder game to ensure. And so when you look at, and in particular, if you look at a new kind of plant, you've got to face the fact that you are developing an infrastructure at the same time, a supply chain, shall we call it. I hear as an exception here and there, it's a regulatory change. We heard about the split and the type of AP1000s and so forth. But I don't think, I hear that's the dominant reason anymore. It is supply chain.
Thank you for admirably concise answers.
Especially because we're running out of time. I'm sure you all are anxious to get to lunch. I want to thank all 4 of our panelists for some really insightful comments. I have learned a lot, and I'm going to bring back to my students and to my own research.